Hi guys! So today we're going to be looking at Final Review Part 2. We're going to start off with a bit of simplification. We're asked here to reduce the fraction 27 over 36 to its lowest term. So I'll give you a few minutes to try this out on your own first. Okay, so right here we have 27 over 36. And I want to find a number that can divide by both of them. I know that for 27 and for 36, we could divide them both by the number 3. So if I divide them both by the number 3, I get 9 over 12. And then from there, I have 9 and 12. I want to check if there's any other numbers that could divide by both of them. I do know that 3 can also divide by both 9 and 12 again, so I'm going to divide them both by 9. When I do that, I get 3 over 4. And so my answer would just be 3 over 4. Okay. Let me clear this. Let's look at fractions to decimals. We're asked here to change 2 over 7 to a decimal. I'll give you a few minutes to try this out on your own as well. Okay, so if I'm changing 2 over 7 to a decimal, I want to start off by changing it into an equation. So right here, we know that this symbol means division. It means that 2 is dividing by 7. So I'm going to rewrite it into the equation 2 dividing by 7. If that's the case, then I can create it by using the in and out method. The 2 is going to go on the inside, the 7 is going to go out on the outside. So 7 is too big of a number. There's no numbers that can multiply that would be small enough to get 2. So I need to add in a 0. And whenever I add in a 0 and then add in a number, I have to make sure to bring up that decimal point as well. And so right here, I get, let's use 2. 2 times 7, that equals to 14. 20 minus 14, that equals to 6, because this will turn into a 10, this will turn into a 1. So right here we get 6. And then I need to add in another 0, drop that down. I could use the number 8, that would be 56. 16 minus 56, change that into a 10 again. This would be a 5. We get here 4. Drop down another 0. We get here, let's use 5. This would turn into 35. This will be 10. This turns into a 3. We get 5. Drop down another 0. And we get, we could also use 7, 6, 7. This will turn into 49. 50 minus 49, that would be 10. This would turn into a 4. This would be 1. Drop down another 0. And as you can see, it's just going to be continuously changing numbers. So this would be 1, turns into a 7. We get 3, and so on and so on. And so let's say that we're being asked here to round to the hundreds. If that's the case, then I'm going to take my 0.28571. I'm going to look for the hundreds place. This is the tenth. This is the hundreds. And so from our 8, I'm going to square the 8 and then look to the right. And since the right number is 5, that means that I'm going to round up. So remember, if you're going to round up, that means that your numbers have to be 5, 6, 7, 8, and 9. If you stay the same, stay the same. The numbers would be 0, 1, 2, 3, and 4. So since we have the number 5, that means I'm rounding up. So my 8, the number that's being boxed, is going to round up 1. So we would get 29. And whatever is after the box, I don't need it. So my answer here is just 0.29. Cool. Alright, let me clear this. And let's continue on. So right here, we're asked to add and subtract integers. For the first one, try this one on your own first. It's asked to find negative 17 plus negative 20. I'll give you a few minutes to try this out on your own first. Okay, so if I'm going to solve for this problem, I first need to start off by combining the positive and negative sign together. Just a quick reminder, whenever you have positive and positive sign next to each other, that stays as a positive. You have a negative and a negative sign, that turns into a positive. Anything that changes where it's different from each other, like the positive and negative symbol, that'll stay as a negative, negative and positive, that turns into a negative sign as well. So right here we have negative 17 minus 20. And so now we have a negative sign and another negative number combining with each other. So when you have two of the same symbols combining with each other, we're going to increase that negative symbol. So number 1, let's just leave the negative symbol there. Then we have 17 and the 20. We're adding them together. We get 7 and 3. So we get here negative 37. A good way of thinking about it is saying that, well, if let's say I owe somebody $17 and I owe somebody another $20, then in total I owe them $37. Let's look at the other example over here. We're being asked to simplify 3, 1 over 2, minus 2, 2 over 3. So right here, I'm going to combine the negative sign and the other negative sign. When I do that, I get 3, 1 over 2, plus 2, 2 over 3. From there, I want to change my fractions into an improper fraction. So I'm going to multiply 3 times 2, that equals to 6, plus 1, that would equal to 7, and the denominator stays the same. On this side we have 3 times 2, that equals to 6, plus 2, that equals to 8. So we get on top 8, denominator still stays the same. From there, because we're adding fractions, we need to make sure that our denominators are the same value. So to do that, I'm going to multiply this side by 3. I'm multiplying the denominator, the opposite denominators with each other. And this side by 2. 3 times 7, that equals to 21. 3 times 2 equals to 6. On the other side, we have 2 times 8, that equals to 16. 3 times 2 equals to 6. I'm going to keep the denominator the same. 21 plus 16, that equals to 7. This turns into a 3, so we get here 37 over 6. Again, if I need to change this into a fraction or mixed fraction, I need to find out how many times 6 can go into 37. I can use 6, we get 36 here. 37 minus 36 gives me 1, and remainder 1. So it tells us here our whole number is going to be 6. And then our numerator is going to be 1. And our denominator stays whatever the denominator was originally. So we still have it as 6. And that would be the end of my answer. Cool. Oops. Last one is rules of exponents. We have here adding exponents, multiplying exponents, and using negative exponents. Let's look at the first one. So whenever we are multiplying two numbers that have the same base, and they're multiplying together, what we do with our exponents is we're going to add them. So adding, this is adding exponents right here, because of the fact that we're multiplying the numbers together. So I'm going to keep my base the same, and whatever the exponents are here, which were the 3 and the 4, I'm going to add them together. So we get 2 to the power 3 over 4, which is 2 to the power of 7. On the other problem that's shown right here, it shows that we are dividing the numbers with each other. We're dividing the 5s. So because we're dividing the 5s, that means that the exponents are going to subtract. So subtracting exponents. That means I'm keeping the base the same, and then whatever's on top, which is the 17, is going to subtract with the bottom exponent. And that equals to 5 to the power of 2. Okay. The only time I'm going to be multiplying exponents is whenever I have parentheses with an exponent on the top. So if we have here 4 to the power of 5, and it's also to the power of 3, in this case, I can change it to 4 to the power of 5 times 3. 4 to the power of 5 times 3 just equals to 4 to the power of 15. And the last one here is rules of exponents. So rewrite 7 to the power of negative 5 using positive exponents and evaluate the results. In this case, when you have 7 to the power of negative 5, I need to change it so that rather than having a negative exponent, I need to have a positive one. So right now, we have 7 to the power of negative 5, and I could change it into the fraction 7 to the power of negative 5 over 1. Whenever we're changing a negative exponent into a positive one, all I'm doing is flipping the fraction around. So instead of having 7 to the power of 5 over 1, I'm going to get instead 1 to the power of 7 to the power of positive 5. So by flipping it, we change our sign into a positive 5. And that would equal to 7 times 7 times 7 times 7 times 7. That equals to, let's see, 7 times 7 times 7 times 7 times 7 equals to 16807. Over here we're being asked to rewrite a fraction with the denominator having a negative exponent. So again, same situation. If the negative exponent's on the bottom of the fraction, I'm going to flip it again so that the exponent that's negative goes on the top, and it's positive now, and the bottom fraction is going to be on the bottom, or the 1 is going to go on the bottom. And so we get here 10 to the power of 8, which is just 10 times 10 to 3, 4, 5, 6, 7, and 8. And that equals to 1, 2, 3, 4, 5, 6, 7, 8. That would be my final answer. Cool. Alright, so hopefully this helped. Good luck.